Hello everyone, you're watching MSK Entertainment Films and today we are back with a new lecture. This lecture is about normal probability distribution. Many of our students and our fellows text us and even they have emailed us and asked about normal probability distribution. So let's move ahead. So today's agenda is making of this normal probability curve, or it's also called a bell-shaped curve. So normal probability curve is also called bell-shaped curve. You may in different books you will read about it and it would be called as Gaussian distribution. It can also be called Laplace Gauss distribution. Now let's move ahead. These are just names, or you can say it as these are the synonyms which can be used instead of normal probability distribution. So how is the shape of normal probability distribution? So first of all, we are going to discuss what normal probability distribution depends on. So normal probability distribution depends on mean and standard deviation. These both give the shape of normal probability distribution. They are responsible for the changes in the shape of normal probability distribution. As we earlier told you that mean and standard deviations are the two characteristics, or you can say the parameters, and which give the shape to normal probability distribution. It gives basically the whole characteristic of normal probability distribution. Now in case we are given with variance, then to convert this variance into standard deviation, we are going to take square root of variance. So for example, if you are given with variance 4, then how to convert it to standard deviation? We are going to take its under root, or we are going to take its power, that is 0.5. So after taking the square root or taking the power of 4 as 0.5, so the standard deviation would be 2. Now this is the example of normal probability curve. So in this case, we are having the peak on 0, which is the mean. In this case, we are having mean 0, and the characteristics and the property of normal probability curve or distribution, it tells us that the probability, the maximum probability would be on the mean. Now, how to make this bell-shaped curve in Microsoft Excel? So for that, when we consider mean 0 and standard deviation 1, then in that case we are having a built-in Excel command, that is norm.s.dist and then open bracket. In case of x, we are going to write the value of x and then we are going to select false and then close the bracket. This is the function form of the distribution. So x is normally distributed with 0 mean and 1 variance. So in this case we are having 1 variance. So to convert 1 into standard deviation, we are going to take its square root. This is a table which shows us value of x and f of x. So we have took the values ranging from -4 to +4, and to find out this f of x value of every single x, we have inserted the values in the above given formula, that is highlighted in the highlighted box, and we got these values, that is from starting from 0.00013383 and then 0.0044318848 and so on. This is the f of x, or you can see the bell-shaped curve of the value on the column x. So you can see that the peak of the distribution is on mean. It is, as we already discussed, that the normal distribution or the bell-shaped curve have the property that the mean would be the highest highest probability would be on the mean. The highest probability would be on mean. In case if you were given with different mean than 0 and different standard deviation than 1, then you are going to use this command, this Excel command, that is equal to norm.dist then open bracket, then insert the value of x, then write your respective mean and standard deviation, and then select false and close the bracket. Now let's move towards the simulation, and we would be comparing the results of the simulation using different mean and different standard deviation. So let's go and check it out. So right now we are going to use the simulation. So over here we are having a normal distribution and mean is 0, while standard deviation is taken as 20, and while sample size is 30 and number of sample is 200. While on the right hand side we are given with a bell-shaped curve. So the mean over here we have approximately 0, or you can say 0.06, while the standard deviation of x variable is 20.04. So right now I'm going to show you, by changing the mean, what would be the effect on the shape of the distribution or the bell-shaped curve. If I increase the mean to 13, so look at the curve, it has shifted right, while the peak has remained on 0.20, while the standard deviation is as it was previously, that is 20.04. But the shape or the mean or the distribution has moved rightward. When I change the mean to minus 22 or any number, so it would shift leftward. You can see it, and the peak is on minus 22, which is equal to, accurately it is equal to minus 19.94 when you round it, so it would be minus 20. Alright, so now if I increase the mean to suppose 5, now then the distribution would shift to 5 and the peak would be on 5. So it is equal to 5.06, while the standard deviation has not changed. Now let's see the effect of change in standard deviation on a bell-shaped curve. So when I change the standard deviation, as we already talked about the mean and standard deviation, then these two parameters or these two changes the characteristic of a bell-shaped curve. So if I decrease the standard deviation to, let's say, 13, so the curve or the bell-shaped curve has shrinked. If I increase it to 17, then the distance between the curve, the inner area, is increased. If I decrease it further to 4, so then the area has furthermore decreased. And the same way, if I increase it again to 25, then the spread, or you can say the distance or the area under the bell-shaped curve or normal probability distribution has increased. So we can justify that by increasing or decreasing the mean, the normal distribution curve or the bell-shaped curve changes its position. And on the other hand, by changing the standard deviation, the spread of the area under the bell-shaped curve changes. So this is all about normal probability distribution. If you have any queries, please email us on mskentertainmentfilms@gmail.com or simply comment it below. Your query would be answered within 24 hours. If you have any topic related to statistics or related subjects, our team would help you to solve the issue or give you a lecture on that topic. Thank you so much.